Hello, welcome to this lesson in mastering statistics. Here, before we can do much more complicated problems with hypothesis testing, we need to get some practice with how to write the null hypothesis and the alternate or the research hypothesis. So all of these problems, we're not going to do the full hypothesis test, but we're going to get practice reading a real problem, pulling out the information from the problem, and writing the null hypothesis and writing the alternative or the research hypothesis. And so when you get practice with that, because that's always the very first step in all of these problems, you have to be able to pull that information out, write the hypothesis down, and then in the subsequent sections I'm going to actually show you how to perform the full-blown test and decide whether to reject or fail to reject that null hypothesis. So let's just jump right into problems. A company has stated that their soda straw manufacturing machine makes straws that are on average 4 millimeters in diameter. So we have a company that makes soda straws, drinking straws, and it says that on average the diameter of the straws is 4 millimeters in diameter. But an employee believes that the machine no longer makes straws of this size, and to test this he samples 100 straws to perform a hypothesis test with a 99% confidence level. And in all of these problems, we're not really being asked to perform the hypothesis test and figure out the answer. What we really want to do is write down the null and the alternate hypothesis. So when you read this problem carefully, you need to see exactly what it's telling you. It says, okay, the first sentence says their soda straw machine makes straws that are on average 4 millimeters diameter. That's what the company believes. But then the new guy comes along, the employee, and he believes the machine no longer makes straws of this size. So notice that all it really says is that the company believes the straws are 4 millimeters and the new guy thinks the straws are no longer 4 millimeters. It doesn't have anything about greater than or less than 4 millimeters or anything like that. It just says originally everybody thinks it's 4 millimeters. The new guy thinks it's not 4 millimeters. So that's important because some of these problems are going to have greater than less than, some of them won't. So in this case, the null hypothesis is what kind of the status quo belief is. And you can see from the very first sentence, what we're talking about is the mean, okay, the average value for the diameter of these soda straws. And the default hypothesis or the null hypothesis is that everyone thinks the mean is on average 4 millimeters. Okay, but then when you read the next sentence, an employee believes that this is no longer the case. So the alternate or the research hypothesis, the new guy thinks that it's no longer 4 millimeters. So on a test or a quiz, when you're asked to write down the null hypothesis and the alternate hypothesis, this is what you're asked to do. The null hypothesis is sort of the default belief, innocent until proven guilty, so to speak, that the soda straw machine makes straws with this diameter. The new guy comes along to challenge it and says, no, it actually isn't producing straws of that size. And we have something like this. Notice that these guys are mathematical opposites. Every possible scenario is contained when you look at the total of the null plus the alternate hypothesis. In other words, either it's 4 or it's not 4. That would encompass any size straw. So they have to be mathematical opposites, and when you take them both together, it's going to cover basically all possibilities of what the machine might be doing. Notice we don't have any greater than or less than here because the actual problem doesn't say anything about greater than 4, less than 4. It just says 4 millimeters or not 4 millimeters. So you need to read everything carefully. All right, so this is really the answer to the problem. All right, but I want to go just a touch further and just kind of discuss. If we read a little bit more into the problem, it says we're going to test this by taking samples of 100 straws. So as we go further in the hypothesis testing, you'll need to know how many samples did you actually choose to test the hypothesis. And that's usually the variable n. In this case, it's 100 samples. And it also told us that we wanted a 99% confidence. So that means that the variable c is 0.99. When you have 99%, you need to put it as a decimal. That's what the value of c is. Okay, now I told you, sometimes we're going to be using c, sometimes we're going to be using alpha. All right, alpha is just simply 1 minus c. So 1 minus 0.99, so 0.01. So if c is 0.99, alpha has to be 0.01. So when c is very high, alpha is very low. When you add these guys together, you're always going to get 1. So it doesn't really matter if the problem tells you the level of confidence c is 99%, or if it tells you the level of significance alpha is 0.01. It's telling you the same exact information. Alpha and c are directly related because they have to add up to be 1. All right, so again, we're not doing the testing in this problem, or in these problems, we're just writing the hypothesis down. The next one, doctors believe that the average teen sleeps on average no longer than 10 hours per day. A researcher believes that the teens on average sleep longer than this. We'll want to write down the null and the alternate hypothesis. Now the difference in this case is, notice the wording is very different. Doctors believe that the average teen sleeps no longer. That means that doctors believe that they might sleep 1 hour, 2 hours, 3 hours, 4 hours, 5 hours. But as soon as you get to 10 hours, no longer than 10 hours means no longer than that. So this is clearly not a case when we have equals or not equals, because the wording of the problem is telling us no longer than 10 hours. So we're going to write the null hypothesis accordingly. Null hypothesis. We're going to use this symbol mu again because we're talking about the average amount of time that teens sleep. So this is a mean. This is a mean value for the population of teens. Should be less than or equal to 10 hours. Make sure you understand this. The first sentence, doctors believe the average teen sleeps on average no longer than 10 hours. Less than or equal to, that's what this means. So 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10 hours because of the equal sign here, 10 hours, but no more than that. And that's what this is saying. The mean is less than or equal to 10 hours. So if this is the case, what would be the alternate hypothesis, or the research hypothesis, or the challenge hypothesis? Well, if it actually says a researcher, who's the challenger, believes that the teens on average sleep longer than this. That means that it has to be greater than 10 hours. So if you were asked on the test, write the null and the alternate hypothesis, this is what you would be expected to write. The null hypothesis is saying that the teens do not sleep any longer than 10 hours. So any amount of time up to and including 10 hours, that is what we call the null hypothesis. But the researcher comes along and says, no, on average, I think teens do actually sleep more than that. So we have to have a greater. Notice there's no equal sign here because the equal sign was here. So all the way up to and including 10 hours, this would be 10.1, 10.2, 10.3 hours, 11 hours, 12 hours, anything greater than 10, right? And then exactly 10 would be included here. Also notice that the null and the alternate hypothesis are mathematical opposites of one another. In other words, the first hypothesis includes every number up to and including 10. The second one includes all numbers beyond 10. So together they include basically all possible answers for how many hours a teen could possibly sleep. And that's how all of these hypothesis tests are going to be set up. When you construct the null and the alternate and you look at it together, it should encompass all possible answers for what could possibly happen. Clearly, a teen, is going to sleep some positive number of hours. And so it's either going to be included here or it's going to be included here. And they have to be mathematical opposites. There should be no overlap between them, but together they should encompass everything. All right. Now let's look at another problem. The school board claims that at least 60% of students bring a phone to school. A teacher believes this number is too high and randomly samples 25 students to test at a level of significance of alpha is 0.02. What is the null hypothesis H naught, the alternate hypothesis H sub A, and C, the level of confidence for this hypothesis test. So we're not really asked to perform the test. We haven't shown you how to actually test and see if you reject the null hypothesis or not. We just want to set it up and write down the hypothesis. Now notice in this case that what we're dealing with here is percentages. A school board claims that at least 60% of students bring a phone to class. Now in the previous two problems, this was the diameter of a soda straw, the average value, so that was a number. This was how many hours a student is sleeping, or a teenager is sleeping, so that's a number. So that's why we use the mean here, mu and mu, because that's expressing just a number, an average value of something. But in this case, it's actually a proportion. Remember, we've done lots of work with proportions. Proportion is just a percentage, essentially. 37% of people ride bicycles. That's a proportion of the population. So here we're going to construct our hypothesis test, but it's not going to include the mean value of the population parameter. It's going to be concerning the proportion. It's exactly the same concept, though. The null hypothesis it says the school board claims that at least 60%, notice the wording, at least 60%. So what that means is the proportion of people in that school, P, is greater than or equal to 60%. But when we write it down, we want to write it down as a decimal. You don't want to put percent signs here. That's just for our convenience. We want to deal with it in terms of decimal, so you shift the decimal back. When we say at least 60%, which is what the wording says, that means greater than or equal to 60%. So anything larger than 60% and also including 60%, that's what the line underneath means. But it says also here that a teacher believes this number is too high. He randomly samples 25 students and blah, blah, blah. So what would be the alternate hypothesis? Well, they have to be mathematical opposites of one another. So that would mean this one would have to be less than 0.60 or 60%. Notice there's no equal to here because that was included here. So the top one is the percentage of students who bring a phone is greater than or equal to 60%, and the bottom one is anything less than 60%, but not including, obviously, because that's already taken care of with the first one. So again, these are mathematical opposites. This is everything above 60% and including. This is everything below 60%, not including 60. Together, though, if you kind of line them up like a choo-choo train, they should encompass all possible percentages that could possibly happen for this problem, the fraction of students that bring a phone to school. So this would be what you would write down for the hypothesis, the alternate and the null hypothesis. This is the status quo. This is what the administration believes to be true. This is a teacher that's researching this. He thinks this is not true. He thinks this number is too high. And so you would set up a hypothesis test. In this case, the problem says we randomly sample 25 students and we basically just ask them, hey, do you carry a phone to school? We're going to get some data from that. Maybe 5 people say that they bring a phone to school. Maybe all 25 say that they bring a phone to school. We don't know yet because I haven't given you all of that information, but the teacher does ask 25 students and he tests at a level of significance of 0.02. So when you see something in a problem, level of significance, you need to write down alpha and write down exactly what it says, 0.02. So this problem said, what is the level of confidence? Well, level of confidence, or I should say, the level of confidence is 1 minus alpha, right? Level of confidence is 1 minus alpha. So basically what you can do is you can say 1 minus 0.02, so 0.98, 0.98. And if you make this in terms of a percentage, it'd be 98%. So this is the level of confidence. And you can see again, alpha plus the level of confidence, they always have to add to 1. So that's kind of just something that you always have to keep in mind. When this is very large, this is going to be very small, and so on. So whether or not the problem gives you alpha or C, it doesn't really matter. You're given basically the same information. You can find the other thing. In this case, what is N? The number of samples that you use for your experiment. N, in this case, is 25. Now, in this problem, I haven't given you all the information to solve it because I didn't tell you what the results of your sampling was. If this were a real problem, I would tell you, hey, you asked 25 students, and here's how they answered. And so we have some equation that we'll show you how to use to go figure out how to test this hypothesis using the sample data that you get. Obviously, you can't ask all the students, but you ask a certain subset of them, 25 in this case, they answer, and it's up to you to figure out when does it become statistically significant. If all 25 of them answer yes, what if 19 of them answer yes? What if 22 of them answer yes? How do we choose the threshold beyond which we're going to reject this null hypothesis or not? How do we choose that? So that's what we're going to get into in the next section. The other thing I'm going to say right before I close is, notice that the alternate hypothesis, sometimes you can get a less than symbol, sometimes you can get a greater than symbol in the alternate hypothesis. Sometimes you can get a not equal symbol, sometimes you can get an equal symbol. So basically you're going to have equals, not equals, less than, or greater than in the alternate hypothesis. That's just the way all these problems are going to fall out. And that's important for you to get right, because what you're going to find out in the next section is the way that you do the hypothesis test is going to depend on the direction that this arrow basically points. If it points this way, I'm going to show you how to do the test like that. If it points that way, I'm going to show you how to do a test. It's similar, but it's a little bit different. And of course, if it's equal or not equal, you have to know how to handle that too. So the way that you actually do the test depends on this symbol. So try not to get that wrong. That's why we're doing this practice here, so that you can get confidence with that. And at that, this is all I really want to get across to you. We're practicing doing the null and the alternate hypothesis, very important skill. Follow me on to the next section. We'll get into a little more of the details and how do you exactly do this testing. Now that you have practice with what the hypothesis is and how to write them, going into the next section, you'll be a lot more comfortable with understanding how do we actually do the testing after we get our sample data.